Good day. Here is a lesson that's going to translate very poorly onto the cloud because this is one of those lessons where it's Socratic. The teacher's asking a lot of give and take and getting your input. So this isn't going to fly as well when it's solo. What we want to do is take a look at how we can recognize elements by their property. And the physical and chemical properties of elements determine their use. Phrased another way, when we plan to use something, the characteristics we need determine the choice or the narrowing of that choice. In many, if not all cases, an ideal substance cannot be found. Hard steel can hold a sharp edge, but it is very brittle. And so if you make a knife hard all the way through, it will snap quite easily. The same is true with diamond. Its hardness makes it as brittle as glass. Gold doesn't rust, but it is such a soft metal it is useless for construction purposes. And your cell phone screens are a careful construction that have the hardness of glass but the flexibility of plastic. And so material scientists are always looking for a way of bringing together the chemical and physical properties they need and have to deal with the ones that they don't want. What are the drawbacks when we use a substance? This is the part that makes me feel kind of bad as a teacher. When we ask a kid to give me a physical property of gold that makes it difficult to work with, they'll say price, except I said physical property. And so here's the problem. When I say physical property, I want you to choose between malleability, ductility, elasticity, hardness, melting point, boiling point, conductivity, density. Okay? Chemical properties would be things like, does it catch fire? Is it toxic? Does it react to other substances? Is it corrosive? Is it caustic? Is it acid? Is it a base? And then there's this whole gamut of other possibilities: social, economic, industrial, geographical. Is it valuable, rare? Does it have a bad ecological footprint? Is it located in countries that are hostile to us? Is it hard to manufacture? Is there insufficient demand for it? Or fear from the public, like uranium? Oh, I don't want radiation, so we have to pass up on something good because of irrational fear. All of these are phenomenal talking points. And as a teacher, I feel bad when a kid puts his hand up and chips in all the stuff that is true, but it's not related to the conversation at hand. So what you have to be careful of is when we ask you to narrow your responses. And unfortunately, the bad part about teaching is very often when we ask you to narrow your responses, you wind up being so limited you feel like you have nothing to contribute. It would almost be in a way like if I said to you, I want you to name any animal you've ever had as a pet, but not any that start with D. And then you're suddenly like, oh my God, I've had dogs and like my selection criteria just blew you out of the water. And so that's the other end. From as a teacher, I want to make sure I give you an opportunity to participate, but sometimes we have to narrow what we're asking you to present. So what happens if on a test you happen to know all this other stuff about these minerals and elements? Well, chip it in, but do it at the end. Now, let's take a look at the atomic table of elements. We want to confine our answers right now to elements only. So if you look on this list, you can see elements that you are aware of. Hydrogen, oxygen. I think most of you know that would be nitrogen and carbon. And we have things down here like silver, gold, mercury, iron, nickel. Okay? You don't see steel. You don't see belly button lint, wood, sugar. You don't see a fork. You don't see lipstick. Those are not elements. Elements are like bricks. Compounds are like buildings that have been assembled from the bricks. There's an infinite variety. So we want to talk about bricks only. So you can't say brass, steel, right? Those are alloys. What are the ones you are likely to learn? These ones. These are the biggest ones that you're likely to see in your life. And you might go, that's a kind of daunting list, but it is most definitely not a daunting list. If you look at these, hydrogen, lithium, sodium, potassium, at most there's one of those you haven't heard of. Magnesium and calcium. I'm sure you've heard of them all. Chrome, iron, cobalt, nickel, copper, zinc, platinum. No, I goofed. That's not platinum. Platinum's there. Palladium, silver, gold, cadmium, mercury, tungsten, lead, tin, iodine, arsenic, bromine, chlorine, sulfur, phosphorus, silicon, aluminum, carbon, nitrogen, oxygen, fluorine, and oh, I forgot. I didn't put the noble gases on here. Helium, neon, argon, krypton. You will have actually heard of the great number of these. So you will not be working with these rare beasties down here that we just don't see very much, okay? So we're confining our answers to what is on this table. The difference between an element and an atom. An atom is talking about a person in general. An element refers to a specific one, say like Mitchell. So it's like saying a student versus Ella. So gold is an atom, but it's specifically an element. There are only 92 natural elements, of which only about 24 affect your daily life. So what I want you to try to do right now is guess what physical and chemical properties are needed for the job being shown and what element you're probably looking at. So what we can see here, this is King Mescalmeduk's helmet from like 2400 BC in Mesopotamia. Okay, so this was a king's helmet. Now, out of all the metals you know, what are the only metals do you think could possibly be a candidate for his helmet and his sword or dagger? Now, they were dug up in this condition. So what is your best guess? There's only about 2, maybe 3 elements on the table with this color. Are you ready, kids? I think it's Natasha. Natasha says copper. Ooh, that's a good guess, Natasha. Copper is certainly that color. But this was a king's helmet. Helmet? Helmet's got an answer about the helmet. Gold. You're right. It's a gold helmet. Now, gold is an easily worked metal. Now, I'm taking a guess here. What properties would this gold helmet have in ancient Iraq that would make it really bad choice to wear, and especially wear on a battlefield? Do you think this king's helmet was put to use on the battlefield? No, it would be a god-awful helmet to wear. You're going to fry your frickin' head inside that thing. It's a phenomenally good conductor. So you put that on in a desert heat, you'd be in such a rage, you probably would want to start a war. You going to go to war with a gold helmet on? No, it's going to cave in the minute someone swats at you. Now, would this be a proper chemistry answer? No, a gold helmet would be a bad choice in battle because everyone else would want to steal your helmet and you would become a target. That may be a valid answer, but is it a valid chemistry answer? And that's what you got to watch, why some of you blow your chance because you didn't narrow your response to the field in view. So yeah, and why do you think this helmet has survived? Why don't we find all the iron helmets? Because there's only one king's helmet. There should have been thousands upon thousands of iron helmets. Where did they go? Why don't we find much of the iron stuff when we dig up these treasure troves? Why do we find gold and not the iron? Now, this is a blimp. There are only 2 possible candidate gases to lift a blimp: hydrogen and helium. So what gas are we looking at here? Well, here's the question. You're all familiar with helium balloons. Do helium balloons explode? Are they flammable? And the answer would be no. This is a hydrogen blimp. And we're going to spend quite some time on the Hindenburg because there's an awful lot we can learn from this photograph. First answer I usually get on this one is chrome. Because darn it, don't they look shiny. And the chrome faucets in our kitchens and in our labs make this a really excellent choice. Steel, no, because I said no mixtures. but chrome is a pure element. I would give you a thing, though. If you could afford chrome goblets, do you know how unbelievably freaking expensive that would be? I've only seen chrome tubing a few times in my life. You're used to seeing chrome plate. If you actually wanted to make these cups out of solid chrome, there would be only a few shops that could do it. Chrome is so brutally hard that you would have one dickens of a time forming these cups. What's going to happen here is I'm going to change these cups' names. These are called chalices. They are used in Catholic services for serving the wine during communion. Does that narrow down what shiny metal they would use in a church service? Do you really think it would be chrome? I'm going to add some further information. These goblets will turn black within a few weeks and must be polished. You got the element yet? Mythologically, this element can stop werewolves. Are you there yet? It's silver. Okay, these are silver chalices. This element here is on this scuba diver's belt, and it's on the tip of these bullets. Okay, not the body. I'm talking about this dull gray metal here. You're wearing it around your belt when you go diving, and it's on the tip of these bullets. Now, why does a diver want to wear a belt? A belt is to make him sink. And there's an old phrase about shooting people saying, eat. The answer is lead. Now, why was lead chosen for both a bullet and a scuba weight belt? Is it its color, its reactivity, or its density? The answer would be density. We've chosen it so it gives us the maximum possible throwing weight and the smallest, most convenient package to help a diver descend. What's a disadvantage of using lead? It's a very toxic metal. And for a bullet, it's also quite soft. So a bullet made of lead will penetrate a human being quite easily, but will be stopped by even the most rudimentary armor. Now, this element glows in the dark. It's used in matches, and it's used in incendiary weapons, which is unfortunately a really nasty event. It can be changed in color, but you can get it in a form. They used to put it on TV screens that glow in the dark. You can get toys, especially around Halloween, like a little skeleton. You hold it up to the light, you shut the room lights off, and it glows for half an hour. Other times you might get little star stickers you can put around your bedroom as a kid. When you shut your lights off at night, they glow for an hour or two. This element is called phosphorus. And one of the giveaways of it used in the military is that phosphorus doesn't put out very easily. It continues to burn, and it's used to set fire to things and people. It's an extremely nasty weapon. You can see here over Lebanon, these are cluster bombs being fired with phosphorus, and you see them here on the ground. If phosphorus gets on you, they're gonna have trouble putting it out. And I'm going to tell you something that gets a laugh in class, but you're going to treat it probably far more seriously now. Phosphorus has one of the most unusual poisoning symptoms going, called smoking stool syndrome. If you were hit by a phosphorus grenade and had enough of it soak into your bloodstream, even if they cut it all off of you, stopped it, treated your wounds, you may now have enough phosphorus circulating in your bloodstream that you will die of organ failure. And you go to the bathroom and your poop actually emits smoke when it hits the water. Now I'm thinking, you may not be a doctor, but if your poop is burning that bad, you probably know you're done for. Now, why would I tell you your poop almost catches fire if you're poisoned with phosphorus? Because I know you'll look it up, and you'll learn a heck of a lot about this element, which is pretty awesome, and it's essential for life. And leave it to good old Homo sapiens to find out a really brutally nasty use for it when it has so many good uses. Now this one, You might think this is gold, but it's a little bit on the dark side and it's a lot cheaper. This might give it away for you. This is copper. Copper and gold may look like each other under the right circumstances, but if I let you handle it, what property would allow you to tell gold from copper apart if the color was the same? And the answer would be density. The gold would be considerably more dense than the others. So, now the next part is to go into unwanted properties. When do we get stuck with a property we don't want? And that's going to be here. We're going to move to iron next and learn about properties of iron when one of the most significant problems with iron, we use it in all our building constructions. We've been using it for centuries, and it has a brutally obvious flaw that makes it undesirable, and considerable industrial attention has been paid to this property of iron for several centuries, and we've never come up with a really clear solution to the unwanted property of iron. Can you take a guess? One of the properties of iron that we don't want, and is it a chemical property or a physical property that makes it difficult to make our buildings and our machinery last? And if you could solve this, you would become one of the world's richest people, and you would do a heck of a lot of good for the environment, and you'd make our world a lot cheaper of a place to live.